Our first question says the cafeteria staff made sandwiches. Each sandwich had either rye or white bread, ham or turkey, and either cheese or no cheese. The staff made an equal number of each type of sandwich. The sandwiches were placed on a tray. Without looking, Mary will choose a sandwich. What are the chances that Mary will get a sandwich with cheese? So I'm going to make a tree diagram for this. So she can choose rye bread or white bread, ham or turkey, and then cheese or no cheese. So my total number of outcomes is going to be how many letters are on the last branch. So there are 1, 2, 3, 4, 5, 6, 7, 8, which means my denominator is 8. And my numerator is going to be how many of those are with cheese. So 1, 2, 3, 4. So 4 out of the 8 have cheese, which would simplify to 1/2. Our next question says, the scores that Joni and Sally received on their first 7 assignments are shown in this table. Which statement is true? Now, if I look at all my answer choices, we are comparing the median. And to get the median, I'm going to arrange my numbers from least to greatest and see which one is in the middle. So Joni's numbers are arranged on the left side from least to greatest, and Sally's on the right side. So if I start crossing off the numbers for Joni, I would be left with a median of 80. And if I start crossing off for Sally, I'm left with a median of 70. So A says Sally's median score is higher than Joni's. So Sally is 70, Joni is 80, so no, that is not true. B says Sally's median score is lower than Joni's. So Sally has a score of 70 and Joni has a score of 80, so that is correct. C says that they are the same, which is not true. And then D says that you can't find the median, but we can. We just arrange the numbers from least to greatest to get the middle number. Our next question says a state representative took several random surveys of adults to find out which place they visited most frequently. The average of all the surveys is shown in this table. So the first thing we need to do is figure out how many people were surveyed. So if I add together 31, 14, 17, and 8, that tells me that 70 people were surveyed. Now we can start to convert these to percentages. So A says on average, 50% of adults visited the zoo. So people who visited the zoo were 31 out of 70. And we want to know if that's equal to 50%. Well, some of you might know that 35 out of 70 is a half, which would be 50%. So 31 out of 70 is not. You could also convert 31 to 70 into a percent. So you would type in your calculator 31 divided by 70. And that's going to give us 0.44, which is 44%. So that is not equal to 50%. B says on average, 17% of adults visited the park most frequently. So 17 out of 70. And again, you might know that percent is out of 100, so this would be 17 out of 100, which is not equal to 17 out of 70. But again, you could convert 17 over 70 to a percent by dividing, and that would be 24%, which is not equal to 17%. C, on average, 2 out of 25 adults visit the aquarium most frequently. So we want to know if 8 out of 70 is equal to 2 out of 25. Well, 2 out of 25 would be equal to 8 out of 100, so that's equal to 8%. Is 8 out of 70 going to be equal to 8%? So 8 divided by 70 is going to give me 11%. So that does not work. And D, on average, 2 out of 10 adults visit the museum most frequently. So 2 out of 10 would be equal to 20%. And then we want to know if 14 out of 70 is equal to 20%. So 14 divided by 70 on the calculator is going to give me 20%. So D is the correct answer. 28, Jane wants to pick out an outfit for the school dance. She can choose from 3 pairs of pants, 5 shirts, and 2 pairs of shoes. How many different outfits does Jane have to choose from? So we could make a list for this, but there's going to be a lot of different outcomes, which means there's going to be a lot of things we have to list out. The easiest way would be to take these numbers and multiply them. So 3 times 5 times 2 is going to give us 30. So that means that there would be 30 different outcomes. The spinner will be spun twice. What is the probability of spinning an odd number both times? So the odd numbers on the spinner would be 1 and 3. So 2 out of 4 numbers are odd. So now I'm going to take that fraction and I'm going to multiply it twice because I'm spinning the spinner 2 times. So 2/4 times 2/4 is going to give us 4/16, and that is going to be equivalent to 1/4. 32 says Paul has spun a spinner with 4 colors: green, yellow, blue, and orange. He spins the spinner 60 times and records each color it stops on. The results are shown in the table. Paul will spin the spinner an additional 450 times. How many times should he expect the spinner to stop on blue? So when he did the trial, he got blue 14 out of 60 times. We want to know if he spun the spinner 450 times, so that's going to be our whole, and then we are solving for our part. So remember, you can do this 2 ways. You can say to get from 60 to 450, I have to multiply by 7.5. So then you would do the same thing up top, and that's going to give us 105. If that's confusing for you, remember that you can also cross multiply. So I would multiply 14 times 450, and that's going to give us 6,300. 60 times x is going to give us 60x, and then I'm going to divide by 60. And that's going to give us 105 equals x. So either way, you will get the same answer. Number 34, Nicole wants to conduct a survey of the opinions of students at her middle school. Which survey sample would give her the most accurate results? So A says random students as they enter the school. B, students during math class. C, random 7th grade students during lunch. Or D, teachers in the 7th grade hallway. So D says teachers in the 7th grade hallway, and we are surveying students, so that one would not work. C says random 7th grade students during lunch, but it doesn't particularly say any grade level. It just says that they are going to survey the opinions of students at her middle school. B says students during math class, so if we only survey students during math class, then we're excluding students who are in any other class, so that doesn't work. So A would be the best choice here, random students as they enter the school. Our next question says Jamal, Gary, Charlie, and Brian are going to stand in a line one behind the other. In how many different ways can they stand in line? Okay, so I'm going to make a tree diagram first, and then I'm going to show you the easy way to do it. So if Jamal is in line first, that means next can come Gary, Charlie, or Brian. And then if Jamal and then Gary go, next it would have to be Charlie or Brian. If Jamal and then Charlie go, then it would have to be Brian or Gary. And if Jamal and Brian go, then it would have to be Charlie or Gary. Right, then if it's Jamal, Gary, Charlie, Brian would have to go next. Jamal, Gary, Brian, Charlie. Jamal, Charlie, Brian, Gary. Jamal, Charlie, Gary, Brian. Jamal, Brian, Charlie, Gary. And Jamal, Brian, Gary, Charlie. So I'm going to write out these outcomes really quickly. Okay, so these are all the outcomes if Jamal is first in line. And so there are 6 different outcomes. Now, if Gary goes first, the same thing's going to happen. There's going to be 6 different outcomes. If Charlie goes first, 6 different outcomes. And if Brian goes first, 6 different outcomes. So that means total, there are 24 different outcomes. Now, the easier way to do this, I have 4 students to choose from that I'm going to put in line. So, for example, if I go tell Jamal to get in line, I start out with 4 people. Jamal gets in line. Now there's only 3 people to choose from. Then if I were to tell Charlie to get in line, for example, then there's only 2 people to choose from. And then if I told Gary to get in line, then Brian's the only one left. So if I multiply 4 times 3 times 2 times 1, that is also going to give me 24. And the reason that number is going down by 1 every time is because if I were to tell somebody to get in line, then there's 1 less person to choose from. So 4 times 3 times 2 times 1. All right, 41 says that we are calculating the mean absolute deviation of the 2 teams. So the first thing I'm going to do is I'm going to add up those 5 numbers. So if I add these up, I'm going to get 245, and then I divide it by 5, and that is going to give us, right, so when we add those up and we divide by 5, we get a mean of 49. So now I'm going to go ahead and write that in my second column, and then I'm going to take the number in the first column and I'm going to subtract 49 from that. Then in the last column, I make everything positive, and then I'm going to add all those up and divide by 5 again to get the mean absolute deviation. So I add all those up and I get 34. I divide it by 5 because there's 5 numbers. And that gives me a MAD value of 6.8. Okay, I'm going to do the same thing now for. All right, so for team 2, I add all those up. I get 214. I divide it by 5, and that gives us 42.8. Right, now I'm going to go ahead and subtract my first number from the mean, and then I make everything positive, and I find the average again. And that will give me a MAD value of 8.96. So now it says, what is the difference in the mean absolute deviations? So now I'm going to subtract these two, and that is going to give me 2.16, letter A. Our next question says, the test scores for the students in Mr. Miller's math class are shown here. What is the range? So for range, we just do the biggest number, which here would be 94. We subtract the smallest number, which would be 52, and that gives us a difference of 42. Right, and number 45, the probability that a person in a certain town has brown eyes is 2 out of 5. A survey of 450 people from the same town was taken. How many people would be expected to have brown eyes? So our first ratio tells us that 2 out of 5 people have brown eyes. We want to know if 450 people were surveyed, so that is our whole, how many would have brown eyes? So to get from 5 to 450, I have to multiply by 90. So 2 times 90 is going to give us 180. Again, if that is confusing, you can cross multiply and get the same answer.